our first presenter. And just to give you a little bit of background, Professor Beckman stumbled upon us on the internet somewhere and did not know that something like Sustainable Minds, that would make it easy for him to integrate environmental sustainability into his course, existed. We were thrilled to meet, and after our first meeting, he signed up and went forward. So, Professor Beckman, please go forward now.
Yeah, thanks, Terry. Again, I'm Eric Beckman. I'm on the Chemical Engineering faculty at the University of Pittsburgh, and I'm going to chat briefly today about my initial use of sustainable minds in my course on product design for chemical engineers. Just briefly about me, I've been teaching here at Pitt since 1989. My research has been focused on green chemistry and green chemical product design for a couple of decades, and so I've been always motivated to try and bring life cycle-based design concepts into my class. About 10 years ago, I created our course here on product design. The course started out as an elective and has turned into a required course since then. As far as University of Pittsburgh, just some salient points to make there is that product design is a required course now at Pitt. Probably the most interesting feature to mention about the department is the explosion in enrollment. It's probably at least doubled over the past 5 years, and it's still increasing. I had almost 80 students in class this spring semester, both for seniors, and we have 135 majors in the sophomore class, so it's still going up. The students are very interested in green design as it relates to their future careers, and they're interested because they know that the large companies that they often end up working for have significant efforts in green design. So green design is no longer a nice to have, but it's more of a must have as far as the students are concerned. A little about the course. Chemical Engineering 614 is the course that I introduce Sustainable Minds to. It's a required course. The vast majority of the students that take it are seniors. These are second semester seniors. And my challenge in bringing life cycle concepts into product design has been really the same for the past 5 or 6 years. Is I have to teach my students everything there is to know about product design in a single semester. And so I can't devote enormous amounts of time to green design. So perhaps I might be able to allocate 2 weeks to green design concepts. So that's a time constraint. At the same time, I don't want to give the students merely rules of thumb on green design. That's not really sufficiently rigorous for engineering students. So when I literally stumbled across Sustainable Minds and decided to use it for the first time, it appeared that it was a way that I could essentially have my cake and eat it too. I could allot the amount of time that I was able to green design and provide something that would be sufficiently rigorous for a group of fairly motivated chemical engineering seniors. Okay, so the question is first, how did I do this? Again, I started working with the staff at Sustainable Minds very late in the fall semester to get ready for the introduction of the software to the students in the spring. And so when I did introduce it, I started with a lecture on what I call the basics of life cycle design, life cycle impact analysis, which involves some descriptions of what full process LCA was, some of the tools that other people use, the BASF tool, the BEAS tool, and then moved to a discussion of Sustainable Minds in class, where I used the toaster example. What I wanted to do is I just show some pictures of the classroom I teach in, and those are at the bottom of this slide, just to show you that this is an engineering classroom. It's very computer-centric. It seats about 85, and there are 42 machines there. What this allows me to do is I was able to run the students through the use of the software up at the front. At the same time, because this is cloud-based, the students were logged into their accounts and could follow along and do their own thing on the machines. So the combination of the software being cloud-based and the setup of my classroom made it very easy to get up and running in terms of the use of the software. Okay, and now as far as the actual project, again, remember that I've got 2 weeks to go through all of green design with my students, given the constraints of the semester. And so I decided to have them work on something they're very familiar with, and that's also a chemical product, and that was shampoo. So what I did was I provided the students with basically a model formulation for shampoo, which I'm going to show you in a sec. And then essentially challenged the students, who work in groups of 4 typically. These are their usual design groups. And I challenged them to, 1, create the baseline assessment. As Terry mentioned previously, there's no such thing as green, but one thing might be greener than another, so we always start with the baseline assessment. Once we have that, I asked them to explore improvements to the formulation that would greatly reduce the environmental footprint while retaining the efficacy. Okay, again, briefly, for those of you that don't know, this is what's typically in your shampoos. As you can see, it's mostly water. What's important here is when you look at this formulation, some of the components were already in the Sustainable Minds database, but some were not when I was looking at this again last fall. And I worked closely with some of the Sustainable Minds staff to either add new data to the database, so to cover compounds which weren't there originally, or we created workarounds where some of the components we turned into assemblies, essentially, so that they can be included in kind of a workaround manner. But working closely with the staff there, going back and forth, I was all ready to go by the time the semester started. And again, when we looked at the formulation, it involved not just what was in the shampoo, but the packaging, what the bottle was made from. Okay, and when I challenged the students to look at creating a greener design, I had them focus on the manufacturing stage of the life cycle, which included naturally the chemicals themselves, and also processes where they were needed. In particular, the bottle manufacturing played a significant role. We included transport, but that turned out to be only a minor contributor to the overall environmental impact. We didn't really worry about end of life for this particular project, mostly because all of the shampoo ends up in the same place, and that's down the drain, so to speak. Although some of the groups did look at what would happen if one used a recyclable material for the bottle. And so there was a little bit of end of use here, but I didn't mandate it. I asked the students to use 1 year's use as their functional unit. Most of them groups assumed about 10 grams per day. And again, most of the groups, when they did the baseline analysis, came up with a product that included about 22 millipoints, which you can see in one of the pictures there. And then the students came up with varying strategies to try and reduce the millipoints through, again, a number of different ideas. And I'm going to show you a couple of examples here now. Okay, this is the strategy of one particular group. They ended up with a 45% reduction. Again, we start with our 22 millipoints. And I noticed a lot of the students did this because of the way the Sustainable Minds results are presented, particularly assigning millipoints to individual components, which the students found terribly useful. For them, it showed them vividly where were the green bottlenecks in the design, some of which they found very surprising because it was sometimes very small components created significant impact. So, for example, one group looked at starting with simple substitutions, in other words, glycerin from vegetable oil instead of glycerin from petrochemicals. And the simple substitutions dropped the number of millipoints substantially. Again, then more what I would call complex substitutions, where they actually had to look at chemicals that could perform similar functions but might have reduced impact. And in this first case here in that box, we're talking about replacing the lead soap with something different. And then finally, and this I find interesting about engineers, is eliminations. Oftentimes my engineering students felt that some of the components that were just there for aesthetics, like the pearlizer, which makes the shampoo look kind of shiny and gives it a certain viscosity, they felt, well, those aren't really necessary, so they eliminated them entirely. I just found that interesting about engineers is they always go for a function over form, and I had to explain that products don't always ask for that. Sometimes aesthetics are very important. Here's another student strategy. They came up with nearly a 60% reduction in bullet points. And again, their first take on this was to try and substitute as many of the petrochemicals with plant-based substitutes. Again, eliminations. And a number of groups felt that having a preservative in shampoo was completely unnecessary. And so a lot of them eliminated the preservatives as an example of making it more sustainable. And then finally, this group looked at redesigning the package, making a more concentrated shampoo using recycled polymer. They ended up with nearly 60% reduction. Okay, my key learnings in the use of the software for the first time is I guess I shouldn't have been surprised at this, but my engineering students picked up the software very fast, over a weekend, faster than I did. They were barely through with the toaster example when they were already pros, and I guess I should realize this. They're all 21 and they're engineering students, and boy, they tore right into it. The cloud basis for the software is very convenient in that we could use it in class, and then the groups were able to use it extensively offline out of the class, which was great. Just an interesting side point is, again, my engineering students tended to discount the importance of components if they didn't provide technical functions. In other words, they just provided aesthetics, like pigment in the bottle, the pearlizer in the shampoo. I just found that interesting. For me is, I guess the key thing was I did get to have my cake and eat it too. I was able to introduce life cycle aided design in a meaningful way to my engineering students in the space of 2 weeks. I really enjoyed working with the SM staff, which allowed me to expand the database and add new compounds, which is great. And I realized that because my students pick up the software so fast, the next time I use this, I can stuff more things to do into this unit because I don't have to allow as much time for them to learn how to use the Sustainable Mind software. I overestimated it at the first time through. Finally, as far as future trends are concerned, my chemical engineering students, typically at least 90% of them, will go from getting their bachelor's degree right out into working for fairly large companies. All of these companies maintain very active green design programs. For example, companies like Clorox have entirely green product lines. So the companies are interested in having engineers who can speak this language. They're interested in having chemical engineers work for them who at least understand the basics of life cycle analysis and can apply it in product design. So the companies want it, my students are very interested, and the Sustainable Mind software allowed me to do this in a tractable way, which worked for me. Thanks very much.
Well, Eric, thank you very much. A quick question came in during your presentation about the formula being proprietary. That was the question. Was the formula not proprietary?
That's correct. What I did was again, many shampoo formulations are proprietary. And so what I did was I did a little searching online, and I looked at the patent literature to get examples of, say, generic shampoo formulations. And so what you saw was an example of what I would call a generic formulation.
All right, great. Thank you, Eric. That was fantastic. And again, the first example that we've been able to present in a chemical engineering course. So that was fascinating for me as well.